Okay. Hi, everyone. My name is Siddharth, and my project teammate is Dan Vikram. And for our data center scale computing final project, we have decided to build a mental health companion as a service with cloud native infrastructure. Next link. So for our brief overview of our entire presentation, it will basically include the project goals. I'll give a small overview of the different software and hardware components that we have used in our implementation, the architectural diagram, and the entire workflow of the entire process of the implementation. We'll give a small briefing about the debugging and testing mechanisms, and then we'll show a working demo of our project as well. So coming on to the project goals, and our main idea is that a lot of people nowadays suffer with a lot of mental health challenges. 1 in 5 adults face mental health challenges, and they are diagnosed with depression. The main problem is that a lot of these people don't really have a lot of resources that they can use immediately to counter this particular problem. And so we have decided to design a chatbot that would offer a much more safer space for people to have more human-like conversations with AI to provide mental health resources and solutions. So a brief idea about our software and hardware components is that with respect to hardware components, we are using the resources from a cluster of virtual machines. So we do use its CPU, RAM, and disk storage. Coming on to the software side, we have a front end implemented via Streamlit. We have a REST API that acts as an intermediate between the front end and our messaging queues, RabbitMQ. We are also using a fine-tuned model, which is Llama CPP for model inference. And we make use of Google Cloud Storage to pull the model weights and to load our model for inference purposes. And for version control and for project management, we have GitHub.
So this particular infrastructure has two components. One is the front end, the other one is the back end. The front end uses Streamlit as its core framework. Once the user enters a prompt, the prompt is forwarded to the backend via a post request. Once that succeeds, it consecutively sends another GET request to retrieve the corresponding response. So the backend itself has three different components. One is the REST server, which is an entry point and the exit point of the backend. Then the messaging queue, which uses RabbitMQ, and the model server. So once there is a prompt from the user, the REST server puts it into a request queue, which is constantly being monitored by the model server. The model server pulls that prompt, generates a response, and puts it back into the response queue. The REST server continuously looks into the response queue and retrieves the response and returns it back to the user. So the entire system uses session ID to uniquely identify each user, so that the system can concurrently handle multiple responses or multiple requests at the same time, return the user's specific response without interleaving each other.
Okay, now just a small overview about the different debugging and testing mechanisms that we have used in our implementation. You'll constantly find that print statements have been used throughout our code to display any sort of bottlenecks and errors. We have especially used them in places like making requests from the front end and when messages and responses are being checked for in the RabbitMQ via the callback function. We have a couple of error handling cases as well, where the messages that go through the RabbitMQ has to be acknowledged first before going further into the implementation process. In case such messages do fail, we have a specific retrying mechanism as well, so that such failed mechanisms are requeued into the RabbitMQ message queues. And then finally, for Flask routes, which act as the intermediate between the front end and the RabbitMQ, all incoming requests are checked for their validity with respect to their data format. So the session ID and the prompt that comes in through these messages have to be in a specific format, which is a JSON format.
So for the working demo, we have the app in here. And all of the different components that I mentioned in the architecture are running inside Kubernetes deployments. So we have separate deployments for front-end, model server, RabbitMQ, and REST server, and their corresponding services so that they can interact with each other. The front end is a load balancer, which means it can be accessed from the outside. Since we are testing it locally, we have used localhost and we have used port forwarding to access it from the local machine. We have specifically used Kubernetes and not GKE or EKS from cloud providers in order to be cloud agnostic. And this is the app. So in case I'm feeling down, I can let the chatbot know. It is going to take a couple of seconds, not more than 30 seconds. So it's empathetic since it's been fine-tuned on several mental health conversations. And we can also ask for support numbers.
If it takes too long, we can probably just ask. Okay, perfect.
Yeah. So that is the demo. Yeah.
Okay,
Thank you.
thank you. Record stop பண்றேன்.